Hey guys, welcome to a new video. In today's video, we're going to look at a Leetcode problem, and the problem's name is count subarrays where max element appears at least k times. So in this question, we're given an integer array nums, and we're also given a positive integer k. Our task is to return the number of subarrays where the maximum element of nums appears at least k times inside the subarray. And by subarray, it means it is a contiguous sequence of elements within an array. So for example, 3 to 3 is a subarray, whereas 1 to 3 is not a subarray because you're leaving out 2 in between. It has to be contiguous. So let's take this example and see how we can solve this question. So I've taken the same example as example 1 here. In this question, we have to find the maximum element first. So first I create a variable max and I assign the minimum possible value, that is minus 2 power 31 minus 1. And now I iterate through the elements. So I check the current element 1, check 1 is greater or this is greater, 1 is greater. So update max to 1. Next I move I forward, I is at 3. Check if 1 is greater or 3 is greater, 3 is greater, so update max. Max is now 3. I will move forward, I is at 2. Check if 2 is greater or 3 is greater, 3 is greater, so it will remain the same. Now I is at 3 again. Check if 3 is greater or 3 is greater. Max will not be updated, it will be the same. Now again I is equal to 4. It is pointing to the element 3. Check if 3 is greater or 3 is greater, both are equal, so it won't be updated. Max will remain as 3. And in the next iteration you reach the end and you find the maximum value whatever is present. Now you have the max value with you. Now we have to check how many number of subarrays where the maximum element appears at least k times. So I keep track of our variable answer. So answer will be a final answer, which is initially 0. So this is a long variable. Now I keep track of count max variable. This will check how many times this max variable is appearing inside the subarray. Now let's implement the two-pointer approach because we are dealing with subarrays and you have to find the number of subarrays. And subarray is a contiguous sequence of elements. So using two-pointer approach, you will get the sequence by finding the elements between the two pointers left and right. So initially we take 2 pointers, left is at beginning and right will also be at beginning. And this right pointer will keep on moving forward until it reaches the end. And in each iteration, you find the distance between left and right to find the number of subarrays. So we start with right. We check if the element at right is pointing to the value 1. Check if this 1 is equal to the max variable. No, it is not. So count max variable won't be incremented. Now check if this count max is equal to k. Because we need to find subarrays, count max variable has at least k number of max values, so it is not satisfying. So your answer is still 0 and move right forward. Now right is pointing to the value 3. Check if this 3 is equal to the max value 3. Yes. So count max will be incremented by 1. Now check if this count max is at least equal to 2. No, it is not. We cannot find a valid subarray now. So right will move forward again. Now right has the value 2. Check if 2 is the max value. No, it is not. So move right forward. Because count max won't be updated and it is still not equal to 2. Move right forward. Nums right is at 3. So check if this 3 is the max value. Yes, it is the max value. So increment the value count max. Count max is equal to 2. So now check if count max and this k is equal. Yes, 2 is equal to 2. So it means we find a valid subarray. So what is the valid subarray? It is this pair. So let me write the answers which I find until now. So one answer is 1, 3, 2, 3. So now we check if this value at left is equal to max. No, it is not. So we can directly move left. So into ans you keep on adding left to find the number of subarrays. And now we check if element at left is equal to max. Yes. So now you decrement the max variable before moving left. So count max is now 1 because now we are moving left forward. And this is the current subarray. In this current subarray, there is only one max element that is represented here. Now check if count max variable 1 is less than or equal to 2. Now count max is 1 and k is equal to 2. Both are not same. So you find 2 subarrays until now. So how are you getting 2? So you add 2 because you add left. Left is at 2. So you add left before moving right. So left was having the value 2. So you add 2 here. Now move the right pointer. The value at right is 3, which is equal to max. So add 1 into the count max. Count max is equal to 2. So the two subarrays which you found until now are, so this is the first subarray and the second subarray is 1, 3, 2, 3, 3, 3. In this the value of k is equal to 3. In this the max value is repeating 3 times, which is at least k. So that condition is also satisfying. And now you have the count max variable to 2 and this count max variable will compare to k. Both are same. So this condition is satisfying. And now we have to move the left pointer. Check if this left pointer is a max value. No. So you can directly move the left pointer. Check if this left pointer again is the max value. Yes, it is the max value. So subtract it now. So count max is 1. Once you subtract it, left will move forward. Now the value of count max is equal to 1. So compare this count max variable and check if it is equal to k. No, they are not same. No, this condition is not satisfying. So you add the value at left. Value at left is equal to 4. So total answer is 6 now. And now you move the right pointer forward. Once you move the right pointer forward, you end the iteration because right is at 5 and you came out of bounds. So whatever is present inside the value answer, which is 6, so 6 will be returned as the output. So what are the subarrays in this? So first you added 2 values from left, and now you have to add 4 values from left. So what are the rest of the subarrays? So this is a subarray 3 2 3 3. Then move left forward. This will be one other subarray 2 3 3. This will be one subarray 3 2 3, and the last subarray is going to be 3 3. So total there are 6 subarrays, 4 plus 2. So 6 will be the final answer. Now let's implement these steps in a Java program. Coming to the function given to us, this is the function name and these are the two parameters, an integer array nums and an integer k. And the return type is long, representing the number of subarrays. And in this question as discussed, first we have to start off by finding the maximum element inside nums. Let's use a traditional way of finding the maximum element inside an array. I create a variable max, which is going to be assigned the minimum possible value. So I'm going to assign minimum possible value. And now I'm going to iterate through the nums where I is going to start from 0 until the end of the array. And I keep updating the max variable by using the mat.max method and comparing it with the current max variable or the current element which is pointing at in the current iteration nums of I. Now outside this for loop, we'll have our maximum variable inside this answer which is being updated here. Now let's declare our output. This is a long variable which is going to represent the number of subarrays. So I'm going to name it count and the count is initially 0. Now I need one variable to keep track how many times we are counting this max because we need to compare it with this k value. So I'm going to create a variable count max which is also initially 0. And now let's implement the 2-pointer approach for which I need a left pointer which is going to start at the beginning and I'm going to need a right pointer, and this right pointer I'm going to declare using a for loop. So until right reaches the end from the beginning and right keeps on incrementing by 1 each time. Now we check if the element pointing at right is equal to the max variable. So if nums of right is equal to the max variable we calculated, then we increment this variable count max. And now we have to check if this count max variable has appeared at least k times. So until this count max variable is equal to k. So once this count max variable is equal to k, we have to do something because it reads the condition that it has appeared at least k times. So when it is at least k times, count max will be equal to k. Now is the time to move the left pointer. So left pointer will keep on moving forward. But before moving the left pointer, we have to check that if the element pointing at left, so if nums of left is also equal to a max variable, which we calculated in the beginning, then we have to decrement this count max variable, right? Because we are moving the left pointer. So before moving, if left was pointing to the max variable, this count max variable should be updated. And now outside this while loop, we keep on incrementing our answer. So I'm going to name it count. Outside this while loop, I'm going to update the count variable by updating the left pointer. Now outside this while loop, we update our output count by adding the value of left into count each time in every iteration. And now outside this for loop, once right reaches the end of the array, you return the variable count. Now let's try to run the code. The test cases are being accepted. Let's submit the code. And our solution is accepted. So the time complexity of this approach is big O of n because we are using a for loop to iterate through the end, where n is the length of the nums array. And the space complexity is constant, big O of 1, because we're not using any extra space to solve this question. That's it guys. Thank you for watching and I'll see you in the next video.